Um, my talk is going to be slightly different than the talks this morning, more so because I'm approaching this very much from a farmer's perspective and what a farmer is looking for in terms of their business going forward. And that's the approach that we've taken in developing our product, which is called Micro AD Farm. Make it plainly obvious what we do. And it's a modular anaerobic digestion solution built into shipping containers that can be applied on small to medium scale dairy farms. So first off, why might a farmer want anaerobic digestion? And this is a really good example picture of what a typical traditional anaerobic digestion system looks like. And those are energy independence, so reducing their existing costs, diversifying their income. This was made plainly clear in the post-COVID period where energy prices spiked. We had a huge amount of farmers approaching us saying they're paying somewhere between 40 and up to 90p a kilowatt hour for their electricity bill. And some of them were going to have to close up shop if those prices didn't come down. Luckily for them, those prices have come back in line with expectations. They're still a bit higher than they were before, but they're following the historic trend for energy prices in the UK of about 5% a year. But it's what happened there. But it's brought into the forefront of everyone's minds what kind of energy resilience is. The second one is reduced emissions from slurry management. This surprisingly isn't as high on our customers' priority list as we would like it to be. A lot of the farmers we talk to, energy is the big thing for them, and the fact that it reduces their emissions is a nice to have, but it's not a key driver for change within their business, often because it comes with a price premium. And so a lot of our customers don't think it's a viable option for them unless it's saving money elsewhere. The other key factor is improved resource utilization. So anaerobically digesting slurry improves the nutrient profile along with correct storage afterwards, and it allows for reduced fertilizer or synthetic fertilizer consumption on the farm. Again, that means a reduced cost for the farmer going forward. What we're also seeing is there's a big focus on the longevity of the farming business. We're seeing a big energy transition in the dairy sector away from human labor, red diesel, and kind of traditional road fuels. So with the human labor side, we're getting a lot more robotic milkers. So the human input is going down and electricity is going up. We're also seeing robotic scrapers, robotic feeders replacing diesel-powered tractors that would typically do that function. And then alongside that, we've got electric and biogas-powered vehicles that are starting to appear on farms. The electric side is going to be much more farmyard-based equipment. So think low loaders, think ATVs. They're going to be electric powered, where the larger tractor type vehicles are going to have to be a different fuel because electricity is so heavy to get onto the fields, and often they don't work. So that's where we've got biogas powered tractors, potentially hydrogen powered tractors. I'm sure Chris might talk about that in his talk in a minute. But equally, we're seeing a transition away from traditional road fuels into compressed natural gas for, say, milk transport. So Arla's got a great milk float with a compressed biogas system there, but also electric personal vehicles as they come to the market more. We're seeing a lot more farmers buying them and wanting to charge them up on site. Now, that's quite difficult. I'll touch on this later, but a lot of our farmers that we're talking to are end of the line. They typically would only have a single phase electric connection or a split phase electrical connection, which again makes putting in infrastructure that generates power very difficult. But I'll touch on that a little bit later. Why specifically are we focusing on the dairy sector? This has been brushed on before, but manure from the dairy sector makes up a massive portion of total manures in the UK. It forms over 70%, of which we think we can generate, or if we process all of this waste, we could generate over 6,000 gigawatt hours a year of energy. To put that in perspective, the new biomethane potential, or new biomethane framework policy that's been talked about in the AD sector has a target of doing 3,000 over the next 25 years. So that just kind of puts the opportunity into perspective for microscale anaerobic digestion. Now, how does that look in the UK dairy sector? This is the spread of farms as described by AHDB, one of the leading statistical analysis organizations in the UK. The majority of farms are between 100 and 500 cows. Some of them have AD solutions in place already, less than 5% though. A lot of the larger farms above 500 cows do have AD systems, but there's a much smaller number of them. So there's only 250 farms of that size, and about a quarter of them have AD systems. How does that amount in numbers of cattle? So over 3/4, or almost 3/4 of cattle are within that 100 to 500 cow range. And that's where we're typically focusing our solution on. So forgive me, these numbers are probably a little bit out of date after the conversations this morning. However, these are some of the figures that we are estimating the reduction from GHG emissions that could be achieved from putting micro AD systems on these small scale farms. There's also other indirect emissions, which is consumption of grid electric power, other fuels on farm for heating, additional diesel that's needed for spreading the slurry on field, and additional fertilizer usage. So this is a great graph from gov.uk that shows the possibility for anaerobic digestion to treat livestock manures. If we lay on top of that the amount of dairy manure, the proportion of dairy manure that could be treated using AD, and then for our systems, that 100 to 500 cow range that we're focusing on, it's a massive chunk of that we can further negate. Unfortunately, given the statistics that we found this morning, that could be much, much higher. But these are using the government's conservative figures for emissions from slurry management. So why isn't it used on small and medium scale farms? A lot of the conversations we've had over the last 5 years with farmers have been, well, why haven't you got an AD system? You've got a lot of cows, you've got a huge amount of manure. Why haven't you treated it? Some of them have. Some of them have made use of those renewable heat incentives and the feed-in tariffs that Angie was talking about earlier. A lot of them haven't. And predominantly it boils down to about 5 different topics. One is management burden. So a lot of the AD plants that have been put in place under those incentives require the farmer to maintain and operate those systems. It's a hugely complicated piece of equipment. Farms by themselves are very complicated business models. There's a lot to think about, and a lot of the farmers just don't have the drive to distract themselves from their farming business model to try and operate an AD plant. The second one is future-proofing. So traditional AD systems are one tank that gets installed. It's a big commercial, civil venture to design and build one of these systems. What happens if the farm wants to grow over time? And that's a big question for these smaller farms because they are much more fluid. So we've heard stories of a, say, 200 cow farm that is planning to grow to 500 cows in the next 10 years. And they've designed an AD system that would be suitable for that 10-year plan. But over the first 6-7 years, they're not generating enough income from the manure that they have on farm already to make that venture worthwhile. Equally, on the flip side, if they built a tank for their farm at that size for now, they would have so much manure in 10 years' time that it wouldn't work, and they'd have to build a second one or a third one. And so future-proofing was a big factor in the accounted for our design of our system. The other one's upfront planning. I think there's another one. That's a very lengthy process. It costs a lot of money. These are big civil works. And so you've got to get the buy-in from a lot of different stakeholders. It's very risky. There's no guarantees. We've seen people spend almost £100,000 on the design and planning process for an AD plant that's fallen through. And so it's high risk, and a lot of farms don't want to take on that risk. So the other one is footprint within the farmyard, and that's quite surprising to me when I came into this, because I thought, farms, they've got a lot of land. Why would they be concerned about a footprint of the plant? And it's to do with the location of that AD facility. It needs to be close to where the slurry is stored. It needs to be close to other buildings around the farm, and typically people's houses are also positioned close to the farm. AD plants might give off odor, and a lot of farmers don't really like the idea of allocating a huge amount of land towards these AD plants, especially in a small farm where the land is tight and they've got often quite warren-y buildings that they have to navigate already, from where they've grown over time, and the next generation has added a new building, for example. And the final one, which is quite obvious, is the cost. So these are massive infrastructure projects. They cost a huge amount of money for the traditional style AD, and they're typically end-of-line applications. So they would need to sink quite a lot of money upgrading infrastructure, grid-scale infrastructure, in order to be able to supply the national grid with three-phase power, as is what is often generated in AD plants. And so it's almost like a non-starter for a lot of farms. Not only is the upfront cost very high, but ongoing operational cost tends to mean the business model doesn't really stack up at the smaller scale. Another point I want to make here is the GGSS incentive, which Angie talked about earlier, is not sufficient. Typically, again, they are put on the end of, well, they're very rural, these applications, and the gas grid just doesn't extend out nearly far enough to reach these farms. And so even that incentive to fund these AD plants is a non-starter. So some of them require energy imports, and that's how they've made them work. Renewable heat incentive and the feed-in tariff works really well. Again, Angie mentioned the stagnation of the AD market over the last 5 years, or 5 to 10 years, as the renewable heat incentive and the feed-in tariffs have dropped off, and that support has stopped, often because the business model for these alone doesn't typically stack up, even on the large scale, and so that government incentive is required to make these work. They're often much larger than originally needed to process available slurry as a result, and they distract farmers from their primary business models. Most farmers are rarely interested, and those who were interested have already installed AD plants. And so the remainder of the market is the ones that we're focusing on, and we're very much focused on reducing these barriers to entry for those farmers, enabling them to use AD systems to upgrade their slurry management infrastructure. So we've took the approach that modularity is a really key point for our design of our product, and that will enable the growth and expansion of the product to suit the farm's demands over time. So one of these things that modularity does is it allows us to build our systems in a low-cost, standardized design on assembly lines. We get a lot of efficiencies from doing that. It allows us to transport them and deploy them very, very quickly. We are able to minimize delays because everything is standardized across all of the farms. And what's more, we're able to relocate products relatively easily. I mean, it's not easy. We have to empty the tanks, but they are portable. So this product is very catered towards tenant farmers who don't want to invest in physical infrastructure, and they might want to take the plant with them as they move, or even sell that on to a secondary market. We've simplified the planning and regulatory requirements. The standardized design falls within the permissible planning rules, so you don't need planning permission typically for one of our installations, and the regulatory requirements are dramatically minimized for these AD systems, and you fall under a waste permit for our product. It's expandable. I mentioned this before. At the moment, we tailor our system to the size of the farm's energy demand, and we match that as closely as we can. As the energy transition happens and people move from diesel and labor to electricity, thank you very much, we will expand systems to match that demand over time. Unfortunately, this means that we don't process all of the slurry at the moment. We typically would process about a third to half of what a farm might typically have in terms of slurry availability. And that, unfortunately, means that there is still some additional methane that's left in the storage afterwards, which we would like to combat. But at the moment, the business model doesn't stack up for processing excess amounts of energy and trying to sell that to third party, whether that's the grid or other ventures. One of the other main benefits for the way we've designed this product is that, God forbid, farmer drives a forklift into the side of the tank. We hope this never happens, but if there's another failure similar to that, we can easily lift our product out and replace it with almost like a hot swap for our digester. And that means that the downtime, that's often something that really impacts large-scale anaerobic digesters, is completely minimized or eliminated. Similar to James's system with the Cube team, we have a centralized engineering team that monitors and maintains these systems remotely. Everything is automated in the product itself, and we're just there monitoring for anything that goes out of bounds, and allows us to prioritize slurry-only treatment without the need for energy crops, and specifically to offset existing costs to the business. And this is what it is. It's a containerized anaerobic digestion system for slurry only. Provides electricity and heat for farm use through burning that biogas in a CHP. We've typically found that a payback is about 3 to 7.5 years for most of our customers, just offsetting the energy consumption on farm only, without the need for any additional support from government. There's also additional savings that we don't typically factor into our business model at the moment, which is reduction in fertilizer costs. There's added value that can be had by the heat use on farm, and reduced operational costs from spreading slurry. And that's why we focus on that 100 to 500 cow range, because our system can be expanded in line with the farm's demands over time. So each 40-foot shipping container that you can see in that will treat about 80 to 100 cows worth of slurry. That will produce in the realm of 12 to 15 kilowatts of electric and about 24 kilowatts of heat output to the farm. Typically, at the moment, the farm will only be able to use a standard, I know there aren't any standard farms, but a standard dairy farm might only use about 30% of the heat that we generate, and the rest will be wasted. We're looking at ways of improving utilizing that heat on site to add further value, whether that's through drying grain, drying firewood, heating other farm buildings, that kind of thing. And that will just improve the business model for the farmer. And I wanted to plug this at the end because I know we've got a lot of government and industry in the room, and I don't often get a chance to talk to you. I often spend my days talking to farmers, which is great fun. But if we were to ask government for some kind of support, we would be looking to make AD an allowable cost within the slurry infrastructure grant. This type of thing has nothing but benefits for the farmer and for the environment. And so I don't understand why it's specifically excluded from the slurry infrastructure grant. And also widen the scope for GHG incentives to include slurry treatment through AD. Things like the biomethane framework, for example, doesn't account for small-scale AD, and in fact, there's some massive shortfalls within that framework that's recently been published. To milk buyers and the industry, what we're really looking for is providing incentives for decarbonising manure management. So Arla has a great example where they provide a premium on their milk price for sustainable actions. If we could see that across the board, that would be a fantastic thing for the sector. and help drive the sector towards net zero. And equally raising awareness for products like ours and Cube, Abatement, as they are available, but we find a lot of farmers just don't know that these technologies are there. So yeah, if we could all as a group help to achieve some of these targets, I'd be very happy, and I'm sure a lot of other people in this room would be very happy. Thank you very much for your time. I hope I was within my my limit. And oh, fantastic! 20 seconds. Look at that. Yeah. Any questions? Sorry.
Yeah, thanks for that thought. Very interesting. You did mention about changing the nutrient digesting the post-treated slurry. And I expect you're getting the increase in ammonia from nitrogen content.
Yeah.
But with that, you also get an increased pH, which for greater ammonia emissions from digesting post-treated slurry. And it was just really see whether and thinking more widely about the situation of mineral management, whether there's anything you can do to lower the pH of the digestate after it's been processed, so that we can reduce mineral emissions from the spread of digestate.
So the question about lowering the pH of the digestates. Is that right?
Yeah.
Yeah.
Yes. That's a very interesting question. It's not something that I know a huge amount about. I know certainly the offset in terms of the methane and nitrous oxide that's emitted through storage and spreading, post-spreading of digestate counterbalances the increase in ammonia. The nutrient profile point is around the conversion of non-available nitrogen into readily available form. And that's the kind of point I mentioned before. I would love to talk to you a bit more about ways that we could do that in a cost-effective manner for this small-scale application, whether that's some kind of additive or some other biological process that we could tack onto the back of our product. Yeah, very interested in talking more about that.
They digest the food waste, including on chemicals. So I wonder whether you see any potential for food waste in the.
So the question from the online audience is whether there's any potential for food waste in this sort of modular type of AD plant.
Yeah. So at the moment, my presentation is very much about the dairy sector. We think there's lower barriers to entry for us as a company to build a sustainable business model in the dairy sector, and that's why we're focused on that first. But that said, we've got ambitions to bring out products for a lot of other waste streams. So pig, I think, is our next easiest target, purely because the slurry is generated in a similar manner. There's also a high energy demand on pig farms. We'd love to be able to develop a product for chicken, but digesting chicken muck is complicated. Food, sanitation waste, those are two kind of key topics that I would like to develop a product around. And we think the base system that we've developed for cow slurry can be adapted for those other waste streams. In fact, the business BioFactory started out developing a sanitation system for low-income communities in sub-Saharan Africa. Unfortunately, COVID made us transition into the dairy sector, and that's what we've developed in the last 4 years. But I'd love to be able to take us back to that initial product and provide something that could service those communities or kind of remote sewage treatment plants in the UK as well.
Thank you. Do you sell these? So do you own them? Do the farmers own them? Do they pay like a subscription fee to manage them remotely? I have to.
So the question was, do we own them? Do the farmers own them? Do we have some kind of subscription agreement? So At the moment, we would be selling our product to the farmer. The farmer would own the asset. They would pay us for an operation and service agreement to keep the plant running. Ideally, the farmer doesn't touch it, doesn't do anything to it, and we manage the whole operation. What we would like to do in the future, once we are a much larger entity and have the cash reserves to back it up, we would like to lease these products out. That provides both the farmer with security, us with security. It means that the customer is never in a negative cash position because the income generated from reducing their energy bills will pay the leasing arrangement. So that's where we would like to get to. Unfortunately, we're not there yet.
That's nice. It's always been to Disney.
Yeah, so the question was around cleaning the gas before it's burnt in the engine. We do have three different processes for scrubbing contaminants from the gas included within the product. So one of which is built into the digester, and then we've got a carbon filter that will remove any kind of hydrogen sulfide, which is the caustic element that really ruins CHPs. And so we try and scrub out as much of that as we can before it goes into the CHP. We don't do any scrubbing of CO2 purely because it's so expensive to do it on this kind of scale. It would be great if there were technologies that become available on the market that we could include in the product to further reduce that greenhouse gas emission and increase the efficiencies of the engine.
There are a couple of online questions. One here says, just to confirm, is the slurry to be processed in your modular AD, does it include flushing and milk waste? If so, have you experienced very low CH4 production or worse, failed operation?
So ideally, we would not take any other water-based liquids. So we would try and take slurry from the cowshed before the milking parlour, typically. For farms where rainwater flows into the slurry management system as well, we would try and take from upstream of that. So we've got as pure a slurry as we can. That being said, milk byproducts such as whey, waste silage, and kind of dumped milk can go into this system, and actually that improves the biogas production. We haven't had any experience of low biogas concentrations or methane concentrations in the biogas. I think our lowest point is about 60%. So we've been either pretty lucky or our system's fairly tolerant to contaminants like that. Obviously, we really don't want people trying to put that in as a way of increasing biogas production, purely because that makes the digestion unstable, and you increase events such as foaming, which could put your digester out of action for a few weeks whilst it's cleaned. Yeah.
There's a couple more questions coming in online. I'm wondering if this is maybe farmers, but is your system run as a semi-continuous or batch mode? And if it's a batch mode, how do you continuously produce energy on farm?
So it's a continuous process. We will provide everything that is needed to go into this, including a pumping skid, which will manage the in-feeder material. We take about 4.5 cubes of slurry a day, spread over kind of 8 to 10 feed cycles. And that is just continuously feeding through the digester and flowing back out at the moment into existing slurry infrastructure. Ideally, they would separate that out, store the digester separately, but we appreciate that on the farms that we're talking to, that's a big cost that they often don't want to invest in yet, maybe in the future.
Are there any other questions from the room at all? Any questions? I have a question. That's okay.
Yeah.
If I'm just wondering, if once you get in front of a farmer and you're able to explain what you've just explained to us, do they seem to respond quite positively? Do they feel like it's something that feels more possible to them to be able to access this kind of technology?
Yeah, I mean, a lot of farms that we first approach will have a preconception of anaerobic digestion, typically from these larger installations that have used the RHI or the feed-in tariffs to fund them. And typically that's quite a bad experience. Like either they have a neighbor that's done it, or they know somebody who's done it, and it's pretty much been negative all around. Either that digester's been a real pain to operate, or it took a really long time to get off the ground, or they spent a lot of money on it. And so that's the initial kind of hurdle that we have to get over. But once they see it, once they kind of understand that it's very much an automated process that is almost plug and play for their existing slurry management infrastructure, doesn't require big civil works. I mean, you can see from the picture, it's a hardcore bed that the whole thing sits on, so you don't even need to put a concrete pad down. That kind of starts changing the mindset often. And we've had really, really positive feedback pretty much across the board, which is great.
There's another question online basically about excess digestate. I guess do they end up producing excess digestate that couldn't be used fully on farm?
Depends on what the land bank's like for the farm at the moment. If the farm is currently kind of overloaded with their slurry production, then we might find that's starting to cause a problem. Obviously, there's a greater nutrient profile in the slurry, and so you can spread it thinner to get the same benefit. And so if you don't have that land bank that's able to receive the digestate, then that starts to cause a problem. At the moment, for most of the farms that we have worked with so far, there's typically been kind of 30% digestate and 60-70% raw slurry that hasn't been treated. And so the benefit isn't quite so aggressive or sharp. And it's kind of a general increase in nutrient profile. So it's not been too much of an issue so far. Excuse me.
Okay, I think we're going to draw this to a close. So thank you very much, Eoin.
Thank you.
Okay.